Alright, how do we make this thing look exactly the same? Counterclockwise rotation, 90. If it's 90, this thing is just going to come over here, right? You're rotating this one point. Remember in the previous videos, 90 degrees. You're taking this point and actually just moving it one quadrant, so it's going to end up here. This would have to go all the way around back to itself. And you know that the bottom of a trapezoid is not the same as, or excuse me, the top isn't the same as the bottom. So the only way you could rotate this thing and make it look the same is if you rotate it 360 degrees. This will not work. Like a 180 for part B would just flip it upside down. It would look like this. Reflection over the X. This is your X axis, so this one would come over here. This one would come over here. And these two would come up here. So you'd actually have it upside down again. And then part D does work, because over the y-axis, this one comes over there. You're on itself, this one comes over here, so you still have the same shape. For number 2, a reflection over line M. This one's kind of difficult, but how you can think about it is, let's talk about the distances. If I pick this point, we would be comparing it, to this point, because this one's 1 down, this one's 1 down. So if we were reflecting it, it would make sense like, hey, this one would have to go on to this one. And it looks like that line is not in the middle, but let's even try another one. Let's try the next point. We would compare it to this one. How close are they? Well, it looks like this one's a lot closer than this one is. Let's even try one even more that kind of shows us maybe a little bit more. So 1, 2, 3, 4, 5. Let's pick the 5th point. 1, 2, 3, 4, 5. Well, it looks like this one's distance is way further than this one. What that means is if I were to reflect this one over that line, it would end up like all the way over here. So we are not going to be reflecting this thing over itself for that, and hopefully that makes sense. And if you keep going further and further, these points get different, like more and more of a different distance. So this point would reflect over here, and then this point would reflect over here. So it's not reflecting over line M. The only way that that would work is essentially if this were like a perfect square. Then we maybe be working out, but we got a rectangle. It's not going to work out. Y equals 1. So let's look at y equals 1, this one right here. Well, if we reflected it over y equals 1, let's compare this point to this point. This one's 1, 2, 3, 4, 5. This one is 1, 2, 3, 4, 5. So yeah, I think that one would work, because each of these points, this one would reflect onto this one. So you're kind of like folding it in half, and it would work. A rotation 90. Remember, rotation of 90 degrees. If I take this point, it's going to go only rotating it one quadrant, so it's going to end up over here, somewhere over here. So if you rotate this rectangle 90 degrees, it's not going to have its width be bigger than its height. It's going to look, it's going to look something like this. So it's not going to rotate onto itself. Rotation of 270, well, this one would go 1, 2, 3 all the way over here. And I think the same situation happens. You'd end up, you can check yourself, but you'd end up with it being like more upright rather than left and right. So your answer is B for that one. Which one has 90-degree rotational symmetry? If you don't know what this means, I put some Khan Academy videos, linked it. But basically what this means is if we got, and we'll do, thankfully this is multiple choice, so we'll do the square first. And actually, I wonder if it's, oh wait. Okay, yeah, we'll do that with this. So rotate it 90 degrees, boom, it looks the same. So the square works. But let's pick another one that maybe I can show. See what we got here. That does have a pentagon. Okay. And so you're right that a pentagon, right, if I rotated it like that, actually that doesn't even look the same. Maybe it's just because how I did it. But if I rotate it 90 degrees, That would be like moving this top point, right, this top point over here. And so we don't have the same looking thing. Like it's not exactly the same it was as in the original. And you can do that, like all of that would happen for all of these. A hexagon, a triangle. They wouldn't have the same exact looking shape. And there is a pretty good Khan Academy assignment where he shows it a little bit better than what I just did. So I would maybe take a look at that. These are saying select all the polygons that have some sort of rotational symmetry. So is there a way that if we had this rectangle that I just kept rotating it, would I ever get it to look the exact same? And I think we can. If I go like this, oops, looks like if I rotate it 180, that one works. So A works for the same reason D works. The only way for I'm pretty sure the only way for the pentagon would be if it is 360, which doesn't count. Like that's kind of like cheating. So is there any other one other than going all the way around that it would look the same? So I don't think these are the same length, but I guess that could actually work. Means I know these are a little bit weird problems, but this is something that maybe works, but I feel like this distance is bigger than this distance. So I feel like the only way a pentagon would work, because like right, this wouldn't work, it's upside down. Maybe that's one I'll look up, and I'll have a little side note for this one, or we'll do this one in class. That one may have one. So let's check out our triangle. Though just the exact way that it is. Boop. Nice, we got this one. We're going. Nothing's working, nothing's working, nothing's working, unless we go all the way around. So the triangle does not work. And the parallelogram, oops. Parallelogram will work. And let's see if we can actually show one. Yes. So 180 degrees works for the parallelogram. So this one, I think it does work. I know this one for sure doesn't work, but maybe we'll do this one in class, try to prove this one. The last one for page 3, oops, does this weird looking shape have symmetry on all of these? So symmetry with line H. Yeah, so if we reflect this, this would go to here, this would go to here, and then this half would go to this half. So that works. Line G. Line G. Line G I think does work. So you would go this one, we'll go to this one. So I think line G works in the same way that line H works. This point would go to this point, and then this half will go to this half. So like this part would fall onto this part, and then this would split over here. So line G works. Line M. Line M works for the same reason line G works. Line N, this would not work. It's that first one that doesn't work, because then this would go like that. So that doesn't work. 90-degree rotation. This point would end up over here. So that one doesn't work. 120. That's interesting. So we have a whole circle. And how many little points do we have? We got 3. So 360 divided by 3 is 120. So the reason why I'm saying that is because if we rotate this 120 degrees, it'll land here. This one would land here, and this one would land here. How do I know that? Because this is 120. This would be 120. This would be 120. So that works. And your 180 does not work because only 120-degree rotation would work, or 240 if you did it more. because if you do it 180, this would end over here. This point would end over here. It's kind of like you're flipping it. So that does not work.